It's 1:38 in the afternoon on the 12th of June 2025. The temperature in Ahmedabad, in the western Indian state of Gujarat, is sitting at 37 degrees Celsius. The wind is light, visibility is good, and the runway at Sardar Vallabhbhai Patel International Airport is dry. A Boeing 787-8 Dreamliner, registration Victor Tango Alpha November Bravo, is lined up on runway 23, holding short of the threshold. The aircraft is operating Air India Flight 171, a scheduled passenger service from Ahmedabad to London Gatwick. On board are 230 passengers, 2 pilots, and 10 cabin crew. 242 souls in total. The captain pushes the thrust levers forward. The 2 GEnx-1B engines spool up. The Dreamliner begins its takeoff roll. 32 seconds later, it will be on the ground, in pieces, embedded in the dining hall of a medical college hostel. 241 people on the aircraft will be dead. 19 more will be killed on the ground. And the question we, as an industry, will spend the next year trying to answer is this. How does a perfectly serviceable 787, with 2 perfectly functioning engines, lose all thrust at 200 feet on a clear afternoon? And why, when investigators finally listen to the cockpit voice recorder, do they hear one pilot ask the other, quote, "Why did you cut off?" I'm going to take you through this one carefully because what the Indian Aircraft Accident Investigation Bureau released in its preliminary report on the 12th of July 2025 is, frankly, one of the strangest sequences of events I've seen in modern commercial aviation. We'll go inside the cockpit, look at the fuel control switches on the 787, walk through the CCTV footage second by second, and then we'll talk about what this means for the industry going forward. Stick with me. Let's start with the aircraft. VT-ANB was an 11-year-old Boeing 787-8 delivered to Air India in January 2014. Series 240, line number 174. 2 General Electric GEnx-1B engines. By June 2025, the airframe had accumulated just over 41,000 flight hours across roughly 7,800 cycles. That's a healthy midlife Dreamliner. Maintenance records, reviewed by the AAIB, showed no outstanding deferred items relevant to engines, fuel, or flight controls. The aircraft had flown into Ahmedabad earlier that morning from Delhi as Flight AI-423, with no reported defects. Crews and engineers turned the aircraft around in the standard transit window, fueling, catering, baggage. By 1:25 p.m. local time, VT-ANB was buttoned up and ready for departure. In the cockpit, in the left seat, was Captain Sumit Sabharwal, 56 years old. Air India line captain with just over 8,200 flight hours, most of them on the 787. He had been flying for the airline for more than 2 decades, and he had a clean record. Colleagues described him in interviews after the accident as methodical, quiet, by the book. In the right seat was First Officer Clive Kunder, 32 years old, with around 1,100 hours total time and roughly 400 on type. Kunder was the pilot flying for this leg. Sabharwal was the pilot monitoring. That's worth remembering because in the seconds that matter most, it determines who has their hands where. The pushback was uneventful. Engine start, normal. Taxi to runway 23, normal. The crew received takeoff clearance from Ahmedabad Tower at 1:38:33 local time. Kunder, in the right seat, advanced the thrust levers. The engines spooled symmetrically. 80 knots cross-check, call-out standard. V1, rotate. The Dreamliner lifted off about 3,800 feet down the runway, into a clear afternoon sky. Now, here's where it gets interesting. CCTV footage from a building near the perimeter captured the aircraft in the climb. You can see the gear coming up. You can see the nose pitch up to a normal climb attitude, somewhere around 12-13 degrees. The 787 is heavy, near max takeoff weight for a London leg, but it's climbing the way a 787 is supposed to climb. At this point, the aircraft is at roughly 200 feet above the ground, indicated airspeed somewhere in the neighborhood of 170 knots. Everything looks textbook. And then both engines wind down. I want to be precise about what we mean by that, because in commercial aviation, an engine doesn't just stop. A modern high-bypass turbofan failing in flight has signatures, a specific spool-down rate, EGT decay, fuel flow trace, N1 trace. In the AAIB preliminary report, investigators state that the flight data recorder shows that both engine fuel cutoff switches, and these are the physical switches on the throttle quadrant between the two thrust levers, transition from the run position to the cutoff position, not at the same instant, one after the other, approximately 1 second apart. The first switch moved at 3 seconds after liftoff. The second moved at 4 seconds after liftoff. Once those switches go to cutoff, fuel is cut to the engines at the engine-mounted fuel valve. The engines start to wind down immediately. On a Dreamliner at low altitude at high angle of attack, with no thrust on either side, you have a few options, and none of them are good. The first thing that happens automatically is that the Ram Air Turbine, the RAT, deploys. The RAT is a small propeller that drops out of the underside of the aircraft, just behind the wing, and it spins in the airstream to provide emergency hydraulic and electrical power when both engines are out. You can actually hear it. Pilots describe it as a deep, droning whine. CCTV footage that surfaced in the hours after the accident clearly shows the RAT extended on AI-171 during the descent. That detail alone told the world, before anyone had seen the flight data recorder, that this aircraft had suffered a dual engine failure. The RAT does not deploy for anything else at that phase of flight. At 8 seconds after liftoff, the cockpit voice recorder captures a transmission on the tower frequency. The pilot monitoring, Captain Sabharwal, calls, quote, "Mayday, Mayday, Mayday, Air India 171, no thrust, losing power, falling." 11 words. That's all there was time for. At 14 seconds after liftoff, according to the FDR data referenced in the AAIB preliminary, both fuel cutoff switches were moved back from cutoff to run. First one, then the other. The engines began to spool up. The 787's flight management system attempted to relight both engines automatically, which is what it's designed to do. One engine, engine number 2, on the right wing, did begin to recover. EGT rose. N2 began to climb. But by this point, the aircraft was already below 150 feet and descending. There was no altitude left to trade for airspeed. There was no airspeed left to trade for lift. At 32 seconds after liftoff, AI-171 struck the dining hall of the BJ Medical College Hostel, approximately 1.85 kilometers beyond the end of runway 223. The aircraft was largely intact at impact, but at a high descent rate and slightly nose-down attitude. The post-impact fire was immediate and intense, fed by the wing tanks, which were still carrying somewhere around 100 tons of Jet A1 for the 8.5-hour leg to London. Of the 242 people on board, one survived. A British national named Vishwash Kumar Ramesh in seat 11A, a window seat in the second emergency exit row, on the left side of the aircraft. He walked out of the wreckage with burns and shrapnel injuries and gave one of the most extraordinary survivor interviews I have ever read in this profession. He said, quote, "I don't know how I am alive. Neither, frankly, do the engineers reconstructing the impact dynamics." His row was the only section of the cabin where the structural failure pattern, combined with the explosive separation of the left main exit, created a momentary, survivable space. On the ground, the fire spread into adjacent hostel buildings. 19 people on the ground died. More than 60 were injured. Now, let's go back to that switch movement. The fuel control switches on a Boeing 787 are not buttons. They're not soft keys on a touchscreen. They are physical, mechanical switches with a locking detent. To move a fuel cutoff switch from run to cutoff, you have to lift the switch up against a spring-loaded collar before you can pull it back. It is, by design, an intentional, two-stage action. You cannot bump these switches. You cannot snag them with a clipboard. You cannot accidentally elbow them on your way out of the seat. The locking mechanism is specifically intended to prevent inadvertent shutoff of a running engine. In 2018, the FAA issued a Special Airworthiness Information Bulletin, SAIBNM-18-33, noting that on some Boeing 737NG aircraft, operators had reported finding the fuel control switches installed with the locking feature disengaged. The bulletin was advisory, not mandatory. It recommended inspection. The 787 uses a switch of the same design family. Whether the locking feature on VT-ANB's switches was fully functional on the day of the accident is, as of this recording, still under investigation. The AAIB report explicitly notes that the switches were recovered from the wreckage and have been sent for detailed examination. But the FDR is unambiguous about the position change. Run to cutoff, one switch then the other, approximately 1 second apart, at 3 and 4 seconds after liftoff. And here's the part that I think every line pilot watching this video has been turning over in their head ever since the preliminary dropped. The cockpit voice recorder. The AAIB preliminary report quotes the relevant exchange. I'm going to read it exactly as it appears in the document. At approximately 8 seconds after liftoff, after both switches have already been moved to cutoff, one pilot is heard to say, quote, "Why did you cut off?" The other pilot replies, quote, "I did not." The report does not, in the preliminary phase, identify which pilot said which line. That identification will come in the final report, which historians of this accident will be reading for years. Let's just sit with what that exchange means. We have two pilots, both qualified on type, both trained on identical fuel system procedures. The aircraft is in the most critical phase of flight, the first 30 seconds after rotation, when you have minimum altitude, minimum airspeed, minimum margin for error. The procedure for moving a fuel cutoff switch in flight is essentially zero. You do not touch those switches between gate out and gate in unless you are executing a memory item for an engine fire or a severe engine damage situation. There was no such situation on AI-171. The engines were normal. The annunciator panel was clean. The exchange on the CVR is not engine fire, fuel control switch cutoff, confirm. The standard challenge and response. It is a question. Why did you cut off? That tells us something important. It tells us that whichever pilot asked the question did not know the switches had been moved. And the pilot who answered, "I did not," is either telling the truth, meaning the switches moved without a human hand on them, which raises a profound mechanical question, or is reporting his own lack of awareness of having performed the action, which raises a profound human factors question. Investigators are looking at both possibilities. They are looking at whether somehow, in a moment of confusion or reflex, one of the pilots reached for a control he intended to operate, perhaps the flap handle, perhaps the gear lever, both of which are on the same center console, and instead moved the fuel cutoff switches. The locations are not adjacent. The fuel switches sit on the lower center pedestal, just aft of the thrust levers. The flap handle is to the right of the thrust levers. The gear lever is on the panel above. These are not controls you confuse if you are operating deliberately, but under stress, under workload, with a fast-developing situation. And remember, at this point in the flight, there had been no fast-developing situation. The climb was nominal. Pilots have, historically, reached for the wrong control. We have seen it before. We have studied it for decades. Investigators are also looking at the switch hardware itself. Has the locking feature degraded? Has there been any maintenance action in recent service that disturbed the wiring or the mechanical assembly? Is there any history of these switches generating spurious signals? The 787 is a heavily networked aircraft. Could a software fault have commanded the engine fuel valves to close independently of the physical switch position? The FDR records the switch position itself. It doesn't record the pilot's hand. So the data tells us the switch is moved. It does not tell us by itself what moved them. I want to say something about the captain. After the preliminary report came out, certain corners of social media seized on Captain Sabharwal's personal life. Reports of recent family difficulties, comments about his medical history. I am not going to repeat any of that here. The AAIB has been clear that it is conducting a full review of crew background, medical records, and psychological profile, and that any findings on those points will appear in the final report. Until then, speculation is, frankly, the worst part of our industry's response to accidents like this one. Captain Sabharwal had 8,000 hours and a clean record. First Officer Kunder was a young, well-rated pilot. They were both, when they walked out to that aircraft on the morning of the 12th of June, qualified to do exactly what they were doing. Let's talk about the response. Within 48 hours of the accident, India's Directorate General of Civil Aviation ordered safety inspections of all Boeing 787 aircraft operated by Indian carriers, primarily Air India's fleet of around 33 Dreamliners. Those inspections focused on the fuel control switch assemblies, the wiring harnesses behind the throttle quadrant, and the locking mechanism. Several aircraft were found with the locking feature operational but degraded, meaning the switches could still be moved with abnormal force without lifting the collar. Those switches were replaced. The FAA, in the United States, issued a follow-up safety information bulletin on the 28th of July, 2025, expanding the 2018 NM-18-33 advisory to the 787 series, and this time recommending mandatory inspection within 90 days of issuance. Several operators have since petitioned for an emergency airworthiness directive that would make the locking feature inspection mandatory, not recommended. As of this recording, the FAA has not yet issued that AD. It is, in my view, only a matter of time. The European Union Aviation Safety Agency, EASA, mirrored the FAA bulletin within a week. Boeing, for its part, has stated in writing that it is fully cooperating with the AAIB investigation, and that, quote, the design of the fuel control switch system has performed reliably across the worldwide fleet for many years. That statement is technically true. Until the 12th of June 2025, no commercial 787 had ever experienced an uncommanded fuel cutoff of both engines simultaneously at low altitude. AI-171 is the first. The preliminary report stops short of assigning probable cause. That is correct procedure. Probable cause comes in the final report, which the AAIB has indicated will be released no earlier than the second quarter of 2026. Between now and then, the world's accident investigators, the airframe manufacturer, the engine manufacturer, the operator, and the regulators in 3 countries are working through every possible chain of causation. Mechanical fault, software fault, human factors, intentional act, they are all on the table. The investigation is not going to be rushed. Here's what I want you to take away from this one. The Boeing 787 is, by every operational metric we have, one of the safest commercial aircraft ever built. The GEnx engine has one of the lowest in-flight shutdown rates of any large turbofan in service. The crew on AI-171 was qualified and rested. The aircraft was airworthy. The weather was benign. None of the conditions that we as an industry have learned to associate with catastrophic outcomes were present that afternoon in Ahmedabad. And yet, in a sequence of events that lasted 32 seconds, 260 people lost their lives. That is the thing about modern aviation. The accidents we have left are the hard ones. We have engineered out the engine failures, the weather encounters, the navigation errors, the controlled flight into terrain that defined the first 60 years of jet travel. What remains is the narrow band where machine, software, and human meet. AI-171 sits squarely in that band. The fuel control switch is a physical control. A human hand moved it, or something in the aircraft told us a human hand had moved it. The cockpit voice recorder captured 2 professionals in the worst moment of their careers, asking each other a question that none of us watching this video ever want to hear on a CVR transcript. We will get the final report. We will get the probable cause. We will get the safety recommendations, and we, as an industry, will implement them. That is what we have always done. The lessons of every accident, Tenerife, Sioux City, Helios, Asiana, Atlas Air, are written into the procedures and the training that keep the rest of us safe every day. AI-171 will be no different. The hostel dining hall at BJ Medical College will become a place that future pilots study. The 32 seconds between V2 and impact will be reconstructed in simulators and discussed in CRM workshops for the next generation of crews coming up through the right seat. This accident was, without a doubt, one of the darkest days in the history of Indian commercial aviation, and one of the most difficult investigations Boeing and the global 787 operator community has ever faced. But as an industry, we will do what we always try to do. We will take these hard-earned lessons, and we will use them to make this profession safer for everyone who steps onto an aircraft in every seat on every flight. Thank you for flying with me on this one. If you want a deeper look at the technical investigation as it develops, the AAIB preliminary report is publicly available, and I'll continue covering this story as the final report approaches release. Until then, blue skies.